Okay, so today we're going to take a look at multiplication and what it is at its core. So multiplication is essentially addition of a certain term a certain amount of times. So the multiplication sign, typically when we get into algebra and beyond, is notated with this dot. So if you see a raised dot between two numbers, it is considered multiplication. It can also be written as two numbers with parentheses between them. If there is nothing in between this parenthesis, it is assumed that it is multiplication. So that's a little bit about the notation. Let's look at the heart of this issue. So if we have 3 times 4, that would be 3 added 4 times. Now, when we do this, we're going to take this first set of 3. 3 plus 3 is 6. 3 plus 3 is 6. So we're going to add those together. We're going to get 12 as our final answer. But what is it, 3 times 4 or 4 times 3? Well, let's add 4 3 times and see what happens. Well, 4 plus 4 is 8. Plus 4 is 12. So we get the same answer. And this is known as the commutative property. Which means it doesn't matter if I write it 3 times 4 or 4 times 3, we're going to get the same answer. So all multiplication is like this. If we have A times B, that's equal to B times A. We can insert anything for the A and B's. These are completely generic. So we could have x plus 4 times 3 is equal to 3 times x plus 4. So let's look at an order of operations. And we know order of operations as PEDMAS, which is parentheses, exponents, division, multiplication, and subtraction. So the first thing that we're going to do, we don't have any parentheses here. We don't have any exponents. Now we have division and multiplication, and that's right here. So that says solve this first. And we're going to expand this like we did with all the multiplication in this video. So we're going to say that's 3 added 2 times. So we're going to get 4 plus 3 plus 3. That will give us, this goes to 7. 7 plus 3 is 10. Okay. Now let's ask ourselves this question. What if we didn't follow PEDMAS? What would happen? Well, you should know that the answer is going to be we get the problem wrong. But we're going to look a little bit deeper than just that. Let's see what happens here. 3 plus, now we're going to say 3 plus 7. So we're not following order of operations. We're just going to go left to right. So this is a big no-no. You shouldn't do this. What we're going to do is just add this times this, and we're going to evaluate this little part first. There wasn't any parentheses in the beginning problem. If it was actually in parentheses, you would do it this way. But it wasn't in parentheses in the original problem. I'm just kind of doing this for my own sanity to group it off. So we're going to do 10 times 3. That's going to give us 30. Let's do it over here. We're going to get trying to multiply. We're going to get 6 times 7. That is 42. Those are not equal. And that should scream to us we've done something wrong, because after all, multiplication is commutative, and this right here isn't commutative. So note that the reason that we follow PEDMAS is that if we don't do it the other way, it just won't work. Essentially, if we were to expand this out, we would get something a little different. So if we had 3 plus 7 plus 3 3 times, so 7 plus 7 plus 7, and then we add them. So let's think about adding them. Now this would be 10 plus 7 plus 7. Well, see, this right here is not the same as this right here. This is saying 10 3 times, where this is now 10 plus 2 times 7. This right here is 2 times 7. So these are not the same thing. Completely different. And they're invalid arguments. This one's valid. This one isn't, as it is written up here. So let's just go through this one more time about what's really going on here so we can see this out. You're going to have 3 plus 7 times 3. That's 7 plus 7 plus 7. We're going to solve this side first. This is what we just did above. This will be 10 plus 7 plus 7, which will be 17 plus 7, which will be 24. This next one is 7 plus 3 7 times, so 3 plus 3 plus 3 plus 3 plus 3 plus 3 plus 3. That's 1, 2, 3, 4, 5, 6. One more. 7. Now I'm gonna kind of highlight these over here. That's coming from the 3 plus 7. Okay. So let's add these up. We're gonna do 3 plus 3, which will be 6, plus, and since we did that, just that being 6, we'll just separate them in 2s here. Okay, so we have a 6 coming from this pair, a 6 coming from that pair, and a 6 coming from that pair. Oh, cool. This is 6 4 times, and we're going to get 24, so it's looking good. Just for good practice, let's add these up again. This will be 12. This will be 12. There's an addition sign between them still. Now let's add these up here. We get 24. Good. So it's important to see that if we did the addition first, the reason that we do addition last in PEDMAS is because it will mess up the argument here. As soon as we break this up into addition and we just add this, it's not going to give us the same answer because we're doing things out of order. Let's take a look at what's going on algebraically. So, algebraically, with variables, 4x would be equal to x plus x plus x plus x. This right here is called a coefficient. The 4 is the coefficient. And we don't know what x could be. X could be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, or 5.772. It could be anything. So what we do is the only information we can add here is how many x's there are. And we know that just like if we added 3 4 times, we could say that that was 4 times 3 because we have 4 of the 3's. Similarly, we're going to do the same thing for these x's, and we know that we don't know what the x is, but we can at least say it's being added 4 times. There's 1x being added to another x, 2 x's, 3x, 4x. So the only information at this point we can give is that this 4x is going to be equal to, well, 4x. Cool, that's valid. What it's not equal to is when we're multiplying between them. So if I had x times x times x times x, well, let's look at this. If we had 2 times 3, well, those are cool because we do know what 2 and 3 are, right? We know that we would just take 2 and add it 3 times. 2 plus 2 plus 2. Or we could take 3 and add it 2 times. It doesn't matter because it's commutative. But when we're multiplying by an x, we don't know what the x is, so how can we say how many times to add the x together? We got to add it x times. Well, how much is x? We don't know. So we can't add this x How many times do we add x to itself? We don't know. So we're going to cover this in a separate video. This is going to do all about exponents. So big takeaway point back here before I move on. These are not equal. Okay, so now we have this question. X plus 5x. And like we said up there, this 5x, we don't know what x is, but at least we know that it's being added to itself 5 times. So we're going to group this here. That's 1, 2, 3, 4, 5. So this will be coming into 5x. And then we're going to just add one more x. So this will be plus this 1x right here. And that's going to give us 6x. And that coefficient of 6x is just telling us to add the x's. How many times was that x added to itself? Okay, so let's solve this one. So the big question here is can this be simplified? Can we make this problem any more simpler? So we're going to try to show that we can't by expanding. The reason we can't, before I actually get into the rigorous showing you how to do it, it's not really a proof, so I don't want to use the word proof, but to show you why we can't simplify this anymore, at least with the skills we have right now, is because we have different bases. So this won't be able to be simplified in terms of x plus 5, in terms of x plus 3 and x plus 4. So we'll show that by expanding it, we can't combine them. So we'll have, this is x plus 3 plus x plus 3, x plus 3, okay. This right here is 5 times x plus 3. And then we're adding, so there's still an addition sign in between it. 7x to the 4th. X plus 4, my bad. X plus 4 plus x plus 4 plus x plus 4 plus x plus 4 plus x plus 4. Okay, I got a few more here. All this is 7x plus 4. But you see here, we're not going to get anything to really simplify. It was already simplified over here. What we can do is distribute this 5 over with the distributive property and simplify and distribute this 7 over. So I'm going to clear this up real quick. And we're going to solve it that way. So 5 times x would be 5x. Then we're going to add 5 to 3, and that would be 15. Plus 7 times x plus 7 times 4, which would be 28. Okay, so we could expand this out if we wanted to, and what we do almost all the time, we never really expand out. The expanding is just to show you why this works the way it does. What we would do here is we just add the coefficients with the same x. So this would be 5 and 7, but they both have an x in common right here. So we're going to say 5 plus 7 times x. And then we're going to just add these constants over here. This will be 15 times 8 would be 3, carry the 1, so that'll be 43. So we're going to take this answer here, move it over here, and we're going to solve this real quick, I guess. So this will be 12x plus 43. So we're going to keep this answer here and keep our eye on it because that's what we're going to prove over here. So if we expanded x out 5 times, we'd have x plus x plus x plus x plus x. That's the meaning of 5 times x. We're going to take plus 15 over here. Then we're going to take 7x. X plus x plus x plus x. That's 6, 7 plus 28. Okay. So what happens then is we're going to just count up all our x's and then add our constants. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Look at there. We're going to reduce that down to 12x, because remember, we don't know what the x is, but we know it's getting added to itself at least 12 times. And then we're going to take that, the 50 and the 28, that turns into 43. And that checks out. So the final thing, now let's look at something where we have 5x plus 3 plus x plus 3. Well, it's an addition sign in between them. That's pretty important to know. So we're going to go and expand this out. X plus 3 plus x plus 3 plus x plus 3 plus x plus 3 plus x plus 3. Okay. And that came from the 5x. It's x plus 3 added 5 times, so this would be this. But we have this little one here at the end, right there, that guy, and that's going to be x plus 3 added. So when we figure this all out, we're going to add up how many times. We don't know what the x is. We do know that there's a 3 there. So let's count up how many times are being added. 1, 2, 3, 4, 5, 6. So that's 6. That's 6 times x plus 3. And over here we should have seen, so if there's not a number in front of the x plus 3, it's assumed to be a 1. So the way you're going to solve these most often is just say, oh, we're going to add the coefficients in front of this unknown since the unknowns are the same. So this will be 1 plus 5 is 6x plus 3. Now we can go a little farther with this one. If we distributed that 6 out to the x and the 3, we would get 6x plus 3 times 6, which is 18. And that would be our final answer. That's completely simplified. So, final one here is if we have just the reverse of this, can things distribute backwards? Well, of course they can, because we're going to have an x plus 3 here and a 3. So what we'll have is we can't have 3x plus 3 times because we don't know what x is. So we just have to use our commutative property here and just write x plus 3 times, which it doesn't matter what order. It'll still equal 3x plus 3, which is also equal to x plus 3, 3. So it doesn't matter where the x3, the 3, this coefficient lands in front of your unknowns. You can always, as long as it's multiplication between them, you can always just evaluate like that. Now the last thing I really want to just touch on real quick is what we would have done, and I'm going to keep almost all of this up. What if this was a subtraction sign in between? Well, if we had a subtraction sign in between, what would just happen is that we would have this quantity minus that quantity. So what we do is we just subtract the coefficients, because this is going to get rid of, this will get rid of one of those. Now we have 4. So this would just be 4x plus 3. We would distribute that 4 through and get 4x plus 12. And that concludes this video. It's kind of a long one, but yeah, you should now know what multiplication is.